Ionic bonding involves the transfer of electrons from one atom to another to form ions. Metals tend to lose electrons to form positively charged ions, and non-metals tend to gain electrons to form negatively charged ions. The number of electrons lost or gained depends upon the element that you have. Again, very simplistically, you will tend to find that the metals will tend to lose electrons to get to what we generally call noble gas electron configuration, or a full shell of electrons, and non-metals will tend to gain electrons again to get to noble gas electron configuration or full shells of electrons. It is always a very shaky area because there are always exceptions to these rules. Note that word isoelectronic as well. Same number of electrons, so they will tend to go to be isoelectronic with a noble gas. So let's just look at some examples of ion formation. Here's sodium. Sodium is a metal. It has one electron in its outermost shell and will tend to lose one electron to form the sodium ion. I've put 3s0 at the end, you'll notice, just for illustration purposes only. You generally do not need to put that at the end. Magnesium in group 2 loses 2 electrons to get to noble gas electron configuration. Chlorine, a non-metal, needs to gain 1 electron in group 7 in the periodic table, and it will form an anion. Oxygen in group 6 will tend to gain 2 electrons to get to noble gas electron configuration. Now notice that the oxide ion O2-, the sodium ion Na+, and the magnesium ion Mg2+, are all isoelectronic. They all have the same number of electrons. So we've talked about the formation of those ions, but what sticks it together? Well, it's that electrostatic force again, and it's the electrostatic force between those oppositely charged ions. So if we have a cation and an anion, they will attract each other. But notice, when we think about structure, that positive charge will attract negative charges from all directions, not just for one anion. We've seen how we can form ions, we've seen what sticks them together. Now when we form ionic compounds, what we do is we tend to look to get a combination of anions and cations to get an overall neutral charge. So for example, if we take magnesium ions, Mg2+, and chloride ions, Cl-, we're going to need a 1:2 ratio of magnesium to chlorine to gain electrical neutrality. The 2+ charge of one magnesium ion is balanced out by 2 - 1 charges of each of the chloride ions.